The prototype-based clustering can be divided into two groups, k-means clustering and k-medoid clustering. In k-means clustering, we aim to find a user-specified number of clusters k that are represented by their centroids. In k-medoid clustering, the centroid is meaningless since the data is in the categorical format. Thus, the most representative item in the cluster would be considered as the medoid. It's good to know that in k-means clustering, the centroid might not exist in the dataset, while in k-medoid clustering, this is a must. So the k-means algorithm is as following. In the first step, we need to get the number of the clusters k from the user. Then, we need to specify a proximity measure, and according to that proximity measure, we need to find the closest centroid to each point and assign that specific cluster to that point. In other words, points are assigned to the clusters that have the closest centroid to them. After forming the clusters, we need to recompute the centroids of the newly generated clusters. We continue this algorithm until centroids do not change anymore. The Vickers stopping criteria would be continuing until only around 1% of the centroids would change. We can use different proximity measures and different centroid types to find the closest cluster for each data point. Examples of proximity measures include Manhattan distance, Euclidean distance, cosine similarity function, and Bregman divergence. The centroid could be the median or the mean of the data in each cluster. In this slide, we overview several well-known proximity measures such as the Manhattan distance, which is the L1 norm of the centroids and the point. Euclidean distance, which is the L2 norm of the centroids and each point. Cosine similarity function, which is the cosine of the angle between the point and the centroids. And the Bregman divergence, which computes the distance in terms of the convex function f between the value of f at point P and the Taylor expansion of f around point Q evaluated at P. You can see the formula of the Bregman divergence algorithm here. We must keep in mind that the distance is minimized while the similarity function must be maximized. There are two important issues that need to be considered in k-means clustering: initialization and the time complexity of this algorithm. For initialization, we choose one centroid randomly and try to find other centroids such that they are at the farthest distance from the first one. In order not to choose the outliers as centroids, choose a set of samples instead of the whole dataset and then find the potential centroid. Time complexity in k-means is big O of I, k, m, n, in which I shows the number of the iterations, k is the number of the clusters, m is the number of the samples, and n is the number of the attributes. K-means is widely used in unsupervised learning since it's a really simple algorithm. In addition, there are a lot of sources available online to get help from. Various implementations exist for k-means and it can be used for large datasets. The disadvantage of k-means lie in choosing the parameter k and the generality of using it for different datasets, since it only works fine with specific convex clusters.